Okay, this is a summary of the normal distribution chapter for students who haven't started or who haven't done much yet. So I'm gonna try to walk you through this chapter. So first of all, we need to understand what a normal distribution is. So let me show you the normal distribution curve and its property. It's a bell-shaped curve. The curve is symmetric around the mean. So to the left of the mean and to the right of the mean, we have the same area. Mean, median, and mode are equal. And let me show you the normal curve right here. You can see it. This is where the mean is. And as you can see, the normal curve extends to the right or to the left without touching. It shows that it is touching the x-axis, but it shouldn't, but it does extend indefinitely. The total area under the curve is 100% or 1. If the standard deviation is small, you will see a narrower curve. If the standard deviation is large, you're going to see a wider and a flatter curve. Now, this normal curve where you have the mean at 0, it's called the standard normal curve. So the standard normal curve has a mean of 0 and a standard deviation of 1. You can see in any normal curve, we can go 3 standard deviation to the right and 3 standard deviation to the left. Anything beyond 3 standard deviation, this is what we call an outlier extreme values, excuse me. So a standard normal curve means where what we have, on the horizontal line are z-scores. A z-score of 1 means the value deviates 1 standard deviation above the mean. This is a z-score of 2, a z-score of 3, -1, -2, and -3. These are z-scores. Now, how do we find areas under the curve? For example, let's say we have z equals -1.96 and we want to look up the value to the left of z equals -1.16. Let me show you a visual of this right here. You see, this is the -1.16, and we're going to try to find the area to the left of it. You can see it's a very small area. There are two ways you can do that. One way is to use the table that is provided in your textbook, and I will usually provide, this table. Or you can use StatCrunch, which I prefer for you to use StatCrunch, so I'm going to show you both. If you're going to use the table, this is what you're going to do. You're going to take the value, which is z equal -1.96. You're going to take the first 2 digit, which is -1.9, and locate them in the first column. And then the third digit, which is the 0.06, and you're going to locate it in the first row. You drop a vertical line from 0.06, a horizontal line from -1.9, and this area right here, this number will be the area or the probability, the area to the left of z equal -1.96, which we can write as probability of z less than -1.96 equals 0.025. Another way you can do that is by using StatCrunch, which I prefer for you to use StatCrunch. I'm going to demonstrate how to use that in StatCrunch right now. Okay, so you go to Stat, Calculators, Normal Calculator, you're going to get this calculator. Make sure your mean is 0 and 1. Anytime you work with Z, you must have 0 and 1 in there. Now, we need the area to the left of z equals -1.96. So that is called the probability of z less than negative. So area to the left is a less than, area to the right is greater than. Now you can see an x here, but actually it should be z. When we work with 0 and 1, it should be z, but the programmer decided to keep it as an x. So if I put negative 1.96 right here and press compute, guys, you can see it's 0.024999979. If you round this to 4 decimal places, it's going to be 0.025. So let's go back to the handout. You can see that right here. So it's a lot faster, easier than using the table. But I will provide the tables. If students want to use the table, they can use the table, no problem. Okay. Let's see, another exercise. The heights of students in a school are normally distributed with a mean of 65 and a standard deviation of 3 inches. What is the probability that a randomly selected student is shorter than 62 inches? So he wants the probability of x less than 62. Probability of x less than 62. If you want to use the table, that would be fine. But in order to use the table, you have to convert the 62 to a z-score. And how do you convert the value to a z-score? You have to put the value minus the mean divided by standard deviation, which is right here. It turns out to be -1. And then you can go to StatCrunch. Let me take you back. And then 0, 1, we're back to z-score. Put a -1 in here and then compute, and you get the answer, which is 0.1587. Okay, let's take you back. Interpretation of the results, 15.87% of students are expected to be shorter than 62 inches. But let me show you how you guys could have done that easily without even doing any calculation, without using the table. We have the mean 65, the standard deviation is 3, and we want to know what is the probability that students will be shorter than 62. Watch. Okay, mean is 65, change it. Standard deviation is 3. And we need a probability of x less than 62. There you go. Hit compute, you get the same answer, 0.1587. We didn't need to change to a z-score or nothing, just using the calculator. Okay. Now, what about if he gives you the area and he wants you to work backwards, just and find the z-score? So as you can see now, you're looking, find the z-score. In the previous examples that I showed you, you are given the z-scores or the x value, and you are asked to find the probability of z being less than a number or z greater than a number. But now we are given the probability, and we need to find the z-score. Find the z-score in the 78th percentile. So he wants the z-score that is located in the 78th percentile. Means find the value for which the area to its left is 78%. So he gives you the z-score, he gives you the area, but he wants you to do the z-score. Let me show you how you could do that using StatCrunch. Okay, so since we're talking about z, it's 0, 1. You have to go back to 0, 1. Okay. He says what z-score is in the 78th percentile. 78th percentile is the area to the left. The area should usually go right here, right here. So I'm going to put 0.78. And since it's an area to the left, we leave the less sign. The less sign here is for area to the left, and the greater sign for areas to the right. And you see this one is blank right here. Just hit compute and you're going to get the z-score. So the z-score is 0.77. This is how you do it using a StatCrunch. Now, if you want to use the table, bring table 5 back, go inside the table and look for an area that is 0.78. You're not going to find exactly 0.78. You're going to find, an area close to 0.78. And this is what I found, guys. I found 0.7794, which is the closest to 0.78. And you can see, guys, if you try to read the z-score from this area, look, the z-score should be 0.7 right here and 7 right there. So it's 0.77. That is, but again, you can use StatCrunch. You don't need to use the table. Next question. Assume that the random variable x is normally distributed with a mean of 50 and a standard deviation of 7. What's the 67th percentile? I'm going to show you how we can use StatCrunch in here. Watch. Just go to StatCrunch, change the mean. What was the mean? I forgot. Just 1 sec. 50 and 7. Okay. He wants what value is in the 67th percentile. Remember, percentile is a probability, and the probability should be in this box on the right. So 0.67 right here. Compute, and here you go. So x is 53.08. That is the answer. 53.08. Okay. So I'll type in x is 53.08. If you are to use the table here, you can use the table to find the z-score in the 67th percentile, and after you find the z-score, you will have to convert it to an x value. Let me show you how. So we go back to 0 and 1, because we're finding a z-score. And you could use the table, you could use StatCrunch, and if I put 0.67 here to find the area to the left, it's going to give me z equals 0.44. How do you change, a z-score to an x value? You multiply 0.44 by the standard deviation, which is 7, and then you add 50. That's how you do that. But you could do it directly, guys, using StatCrunch. Just enter the mean, which is 50. Enter the standard deviation, which is 7. Enter the area here, which is 0.67, and compute, and you get the answer. You're done. Okay, next one. This is a good one. The mean score on a standardized test for admission to a program at a school is 375 with a standard deviation of 110. A college would accept applications from students who scored in the top 10%. What minimum score would place a student in the top 10% of all scores? Let's say, guys, you took this test and you want to see that you will be accepted, at this college. So you want to check if your score is in the top 10% of all scores or not. Here's how you do it. We can do that. It's very one step in StatCrunch. Watch. So I'm going to go to StatCrunch. Okay, 375 is the mean. Standard deviation is 110. Okay, top 10%, guys, means an area to the right. You should be, just above the mean, so you're heading to the right. So we need to change this one to a greater than. And the area, remember, it's always in this box here. So I'm going to put 0.10. And you're going to see the graph that reflects on that. You see, the red should be on the right. So students who are from here and up are the top 10%. What is the score, that lowest score that would place the students in top 10%? 515.97. If you round it, guys, it would be 516. So our students would have to get 516 and more in order to be a top 10% student. Let's go back and write it down. X is 516 or more. That's it. You can do it using StatCrunch this way. So this is the first video. Now I'm going to follow this with another video with some more applications, and then there will be another one for section 8.1.